Welcome everyone. Thank you for joining me today on my advanced SD-WAN catalyst SD-WAN troubleshooting session. We will be talking about policies specifically, and my name is Eugene. Probably some of you have seen me before during the week. We have a lot of material to cover, so let's start without any further delay. But before I start, I really would like you to join to this WebEx space. Again, just because I have a lot of material, I may not have enough time to answer questions during the course of a session, but I have a couple of brilliant colleagues. We are my teammates, Bradley and Scott. Bradley, Scott, yeah, thank you. So they are right now in that space, and they will be helping me to answer any tricky questions you may have. But again, the point is that we won't be closing this space on 27th of February. We would like to use it to stay in touch with you. If you have interesting questions about policies, tricky cases, feel free to reach out to us to discuss. Let's stay in touch and connect. Okay? So let's move on. Session baseline and objectives. I'm not here to entertain you. I'm sorry. I'm here to teach you how to troubleshoot policies. And this is advanced level session. So I cannot, unfortunately, cover all of the basics of Catalyst SD-WAN, and we will be touching only most critical, tricky points or something which is really necessary to recap if we are talking about policies troubleshooting. Session main objectives. The first one is obviously demonstrate policies troubleshooting tools and techniques on how we use it and how we troubleshoot it. The second one is to share our experience about some interesting or tricky issues seen in the field, like maybe some TAC cases. All of the material here is based on real experience. It's not something theoretical, it's rather based on the practice. First, we have seen it in practice, and then we made this session to share the experience with you. In fact, this session was originally made for myself like a set of notes about different interesting studies, and then I decided why not to share it with our customers. So it's not a marketing session, it's really an engineering session. Right? It's not a comprehensive guide, unfortunately, right? First of all, because in 90 minutes format I cannot cover everything, and at the same time, certainly that the amount of problems which may arise around policies and routing is just huge, right? So I apologize in advance if I didn't cover something, but reach out to me and let me know what you would like to see maybe next year, right? Consider this session as a cookbook. What do I mean by this? Cookbook, you can use it later during your troubleshooting efforts as a cookbook. So it can guide you through a set of steps to resolve your issues regarding the policies. And it's not a tour de force, again. Some of those issues we were troubleshooting for days or even sometimes a week, which I'm talking about here, and I'm trying to present them in a very condensed manner within this short period of time. That's why I apologize in advance if I delay you for additional 5 to 10 minutes, and appreciate in advance if you stay with me for 100 minutes, not 90 minutes, okay? Are you all okay with this? Please. Perfect, so then I will delay you. Most of you voted for this. The session primary focus on centralized control policies, but we will also touch localized policies a bit if they are related to the troubleshooting workflow, right? And main topics, workflow, obviously, troubleshooting workflow, toolset, internal components of iOS XE. It's also important to touch and to explain briefly if you want to check policies programming under the hood of a router. And finally, there is a small section about common pitfalls as a conclusion, right? So certainly this is mostly CLI-based, old school, right? Because this is how we troubleshoot it, but certainly whenever necessary, UI, we manage UI tools are also shown, but mostly, again, this is CLI-based. And as a prerequisite, not sure if all of you checked the session agenda and session description, it's good to review the other session from past years about routing troubleshooting. Why? Because routing and policies, they go hand by hand, right? They are all interrelated. If you didn't, no worries, maybe you can do it later, right? Or I'll also touch briefly some of the most important concepts as well. Quick agenda, so it's easier for you to navigate later through a slide deck once you have it. And one more important thing about the slide deck. In your application, if you If you don't see CLI outputs, for example, this year, I think the setup is perfect. Just we have 4 screens and it should be better, right? If you still want to follow it on your, let's say, laptop, it's in your application, some slides available, but in fact, I have twice more slides, and most of them, not most of them, half of them are hidden. I'll ask to publish them later in the on-demand library as well, right? So what you see now, you just follow what is on the screen, but additional slides are also will be available later, so make sure to check the on-demand library, okay? Yet another grounding rule, right? Tell me who prefers old names vBond, vManage, vSmart. Awesome, awesome, I prefer them too. So that's why I will stick to those names through the course of my slides, just because I like them, right? Well, reality is a bit more complicated. Those are marketing names, but in all of the CLI outputs, not mostly, in all of the CLI outputs, we still use legacy names, and we are not planning to change it. So to avoid any kind of confusion, I'll stick to the legacy names, but sometimes I certainly will use the terms interchangeably, so bear with me, okay? So without further delay, let's jump straight to the policies overview. As I said, only basic concepts, not all of the details we will cover. The first part, the major part of the policies is so-called centralized policies. The policies which you define, and then they have something common in between them. The common thing is that we are defined on vManage usually, and for sometimes certainly for test purpose you can modify them directly on the smart controller through the CLI, but nobody doing it, even we. So we define it on vManage. vManage program them. We not really program it, just send the netconf XML configuration to the smart controller, and then the smart controller will either will execute those policies itself if we are talking about topology and VPN membership policies, or it will send them further through the OMP session if we are talking about traffic rules. One more important thing to consider. If you're familiar with vManage UI, we have a classic UI, which is basically templates and policies, and we have a modern UI, so-called UX 2.0. UX 2.0 is the common name for policy groups and configuration groups. So what is important is that topology in VPN membership policies are merged into the single instance of topology, right? And traffic rules, which are application-aware routing, data policy, and so on, they are called policy groups, application priority, and SLA. The second big part, so as I said, we are enforced either on the smart controller, if it is centralized control policies or VPN membership, or if it is application-aware routing and data policies, we are sent over the OMP protocol in a special form. We will talk about it, and then we store it on a router, right? The second big part is so-called localized policies. Localized policies usually is just a set part of your device template. But again, the important thing to remember that in UX 2.0, they will be also a part of the policy group. So basically localized policies and centralized policies partially merged together under the instance of policy groups. It's also important from a troubleshooting perspective. I'll show you in upcoming slides why, right? The next important concept to remember is what are the building blocks of centralized policies. Not specifically centralized, it also applies to localized policies, but still in general. The first one is a group of interest. So what we are making our choice based on, what we are matching based on. It's like imagine you have a brick, right? And from a brick you can build a wall. So the wall is your policy definition. All bricks together, so basically you combine your rules and you do something with those rules, right? But the wall alone is not enough to build a building. So you need to define in which direction this wall is set up, right? So altogether, when you define in which direction this wall is set up, will be your policy application direction, right? So altogether, it forms a centralized policy definition. So match conditions, bind it together into sequences with actions is the policy, and then policy applied into some direction. If it's a centralized control policy, inbound or outbound from the perspective of the smart controller, if it is, let's say, application-aware routing, no. If it is data policy, it may be from service or from tunnel, right? We will talk about it. But enough about concepts. Like most likely, most of you are aware about those basics, but knowing those basics we can come up with a generalized policy troubleshooting workflow. What needs to be checked? And the good news is that some of those steps, like for example, check if template already assigned to vSmart will be done automatically by vManage. So if you try to do something which is not supposed to be done, vManage will basically send you a warning message or will prevent you from falling into troubles, right? So the top part is more or less automated because it's done by the vManage controller. But certainly there is a bottom part. And bottom part is when the configuration is sent, let's say, to the smart controller, so it is executed there, or if it needs to be sent further to a device, to a router, to be enforced here, to be enforced there, like application-aware routing or data policies. Again, this is for your reference mainly, because I said the slides are for you, so you can use them on your day-to-day troubleshooting, during your day-to-day troubleshooting tasks. We will go into details about all of those steps in upcoming slides, right? So we will start with top part, the top part about vManage. Relatively simple. Let's start with something easier, right? So first of all, how to check if everything is all right with your policies? You first need to ensure that you have applied a configuration to the smart controller. If configuration is not applied to the smart controller, you cannot apply policies. Because I'll tell you something. Policies are basically a part of show run of the smart controller configuration, right? So policies definition is basically part of show run configuration on vSmart. As simple as it. But again, from a point of vManage, this is what you are verifying here, if template is already assigned or not. Once template is assigned, you may maybe define it with policy successfully, but if you have not activated it, obviously it's not, it's not doing anything. So the next very basic step is to verify if policy is activated. If policy is activated, but if it is UX 2.0, which is supposed to be your favorite way of configuring policies nowadays, right, or in the near future, there is a trick already. When you change anything in a classic UI, you are automatically triggering the policy deployment workflow, right? It cannot happen that you defined something and forgot to apply it. Or it cannot happen that multiple engineers, network administrators, doing something regarding policies and one did something while the other was not aware, right? But with UX 2.0, on one hand, it's more flexible, on the other hand, it's prone to mistakes. If you forgot to deploy it after you even activated it, some of the changes may be missing. So always keep in mind, you need also to deploy the changes. And more importantly, we have enhancement requests, and few people already reached out to us today. Guys, keep me honest, during the lab. All we notice it all the same. So if changes are made to the topology policy, you don't see out of sync message or any kind of warning saying that policies are not deployed yet, unlike configuration groups and policies groups, right? So the topology won't warn you. So always keep this in mind because sometimes it may cause some troubles, right? So the next thing is if you try to activate the policy, this is what vManage is helping us to prevent. If you try to activate the policy or deploy the policy and there is no device template assigned to vSmart, it will simply forbid to do so and will tell you, look, you don't have template assigned. The other useful thing which vManage can do, even before it tries to apply it to the smart controller, it will check the syntax locally on vManage itself and try to see if there are any kind of issues with the policy definition you made. For example, here is a mistake that your administrator trying to break the rule and assign the same site ID to multiple site lists. So it basically may cause the fact that multiple policies will be making may collide and make different decisions based on what is matched, right? So it will prevent and won't allow you. When we are talking about localized policies, it's quite simple, right? This is a device template, and as a part of a device template, you have a section called policy. Or if it is a security policy, it's also called a security policy. So once again, it's just a part of a device template, right? Nothing special. If we are talking about UX 2.0, again, things becoming a bit more complicated. Because we are mixing all together the policy which is stored as a part of a device configuration and the policy which is stored as a so-called volatile RIP, You don't see it as a part of a show run config. You rather see it, again, we will talk about it, but show SD-WAN policy from vSmart. This is what is called volatile RIB, and you can see it here. For example, application priority, this is nothing but application-aware routing, right? But an NG firewall is a part of a show run configuration, basically a firewall config. They are merged all together. And the problem remains also the same. You need to deploy it. You may have changed it, but if you forgot to deploy it, so obviously we won't take effect. Next thing, since configuration group since the policy group relies on the configuration group, yet another class of problem, small, not really a class, but yet another problem may arise regarding the UX 2.0 configuration groups. You see, right, that this is checkbox is grayed out. You cannot check it. Why? The answer is already on the screen. If you're attentive to details, you will see that there is no config group assigned, right? While config group is not assigned, you are not able to apply configuration group because configuration group, again, sometimes is a part of the, because a policy group sometimes is a part of a configuration group, right? Just assign the configuration group first. Yep. So the next thing, which is also sometimes helpful, is that if it is part of a device template, we manage again. It may try to apply the configuration directly to device, or it may start checking it against the localized policy, localized schema definitions, right? And here it's not yet sent the config to the device. It's checked it locally against the definitions of its own syntax known to it, and it found that apparently something wrong with BGP ISPath. ISPath, if you're really curious, it was just a typo. Some symbols were entered twice, right? But we managed already prevented this prevented you from having further troubles while you are trying to attach the device template to a router, right? And the last, but not least thing, which is very useful troubleshooting skill while dealing with policies, is to be able to navigate through the CLI view of the policy. So why? Because sometimes you may define it, it may happen that you define it policy on vManage, and it looks completely logical, right? Like there is a sequences, there are rules defined, but then later you apply it on the device and it's not functioning as expected. Why? Because the policy is always translated into CLI view, and this is the very first step which can help you, if you are comfortable with CLI policies, to understand what is actually policy doing. If it is really translated from the intent view, from the graphical view into something useful for the vSmart CLI. So for classic UI, you can click preview and it will give you the CLI policy even before you try to apply it to the smart controller, right? Okay, that was more or less easy, the vManage part, but now policy maybe arrived to the smart controller via netconf session, right? Maybe it's a part of the smart configuration, how to troubleshoot it. And let's talk about few most important concepts in regards to centralized control policies troubleshooting, which I call 101 troubleshooting course on centralized control policies. The most important concept is to remember that you can apply policy on ingress direction from a perspective of vSmart, right? And then some of the paths may be excluded from the best path selection, right? It means that the policy may influence on what the best path calculation on the smart controller will be applied onto. And then the result of best path selection will be sent to all of the devices connected to the smart controller, right? While with egress or outbound policy, the situation is different. So let's imagine that multiple devices are sending update about the same prefix. Best path selection algorithm may already influence what will be considered by the outbound policy. So maybe it's an equal cost multipaths, or one path is better than two others, right? And then with policy action, you can also define, with outbound policy action, you can also define who will receive that update, and all others may not receive it or may receive unaltered update, right? It's very important to understand. Again, the policy on inbound before the best path selection, the policy on outbound after the best path selection, right? First concept. So Knowing this concept and SD-WAN policies basics already more or less enough to come up with a generalized policies troubleshooting workflow. And workflow, again, is for your reference. We will certainly take a look into details of those commands in coming slides. But there are 5 major steps. Step number 1, to ensure that changes arrive on the smart controller. The easiest way to do so is to check configuration commit changes. It will tell you the timestamp and who did the changes and the diff, as it is seen on vSmart, if configuration arrived on vSmart, certainly. But step number 2 is basically to ensure that we have a peering with some routers. If we are processing routing information or T-logs, for example, right, we need first to ensure that there is a source of this information which needs to be processed by vSmart controller. The step number 3 will be to check what are the policies applied to a particular system IP, to a particular peer. Right? And there is a support level command available. We will take a look in upcoming slides what is really want here. You don't. This is very long output. You don't need to navigate through it visually, right? You always use filtering, and to find all policies applied to the peer, you are using include poll keyword, so it will show you the policies. Next step. Okay, now you know which policy applicable to that peer. Maybe you're troubleshooting centralized control policy. You found in which direction it's applicable, inbound or outbound. Now you want to see this policy, right? Again, don't scan the whole show run of vSmart. It's impossible sometimes. You be wise and use your configuration, show run configuration modifiers. Like show run apply policy will show you only the section about this particular site ID. Show run policy list will show you only specific building blocks of the policy, like the lists, let's say site list or T-log list within your policy. Show policy control policy, show running config policy control policy on vSmart will show you the actual policy of a name given here, right? And the last thing, but not least, when we are talking about centralized control policies troubleshooting as such, is to test the policy match condition and actions. We designed it long ago in 20.8, not just designed it, we asked it to implement our developers' troubleshooting tool called test policy. And again, we will check later, we will see some examples on how to use it. Last but not least, I already mentioned a couple of times, the policies, they go hand by hand together with routing, right? Because the policies obviously influence the routing. So if to that point there is something still wrong, maybe simply the source of your information or source of your routing information simply does not advertise the route or T-log for whatever reason, then again, I suggest you following my breakout session about routing troubleshooting from the previous years in the on-demand library, right? There is always last resort option available. And I keep telling the same to my TAC engineers. When they ask me what kind of debugs I need to enable, I'm asking them, hey, have you verified basics before you enabled any kind of debugs? Debugs is like a noisy thing. It will give you a lot of information, very cryptic. We guys, again, keep me honest. We sometimes don't understand what is in the debug printed, right? So, but it is sometimes still useful option. You can enable debug, and in debug, more or less, if you use your common sense, you can understand, let's say, why policy is discriminating some prefix or doing something regarding some other prefix. The important thing about policies to mention is that before 20.12, we were storing those policies in so-called temporary location. The advantage is that we are not writing it to a disk and not like using the disk IOPS, but at the same time, if devices, I mean, vSmart reloaded, all logs are lost, right? So starting from 20.12, we decided that it must be a permanent location, but by default, it's not enabled. You need to enable it. And to enable this permanent location, you need to configure system logging disk enable, right? And the level of debugging. That way, you can still enable debugs, and to view them, no matter which version you use, there are multiple options available, especially if you're using Linux operation system on day-to-day basis. Maybe the option from vShell is the most preferred for you, right? Again, I mentioned that there is a prerequisite to my session. Maybe not everyone checked the description. That's why very quick recap on the routing troubleshooting workflow, right? Because again, it's very important for the policies to understand if routing is doing its job, if necessary prefixes or T-logs are actually advertised. So we will use a very simple topology for the sake of demonstration. This is a service-side router. I have a couple of SD-WAN routers, and one router originating some prefix. It is sending it to the smart controller, and the smart is supposed to send it to the destination. We are not talking about policies here, right? Imagine that the policies we have checked already, everything is fine, policy arrived, right? What else? The policy, we check it if peer exists, so there is a peering established in between them, right? When we check it visually show run, we check it the policy is as we define it on vmanage, and then what's the last thing? We did a test. We tested policy and check it that the policy is matching to a condition and doing the necessary actions, right? So what about routing? Very simple. Always start with basics. Check the routing and forwarding tables. Show IP route and show SD-WAN IP fib. This is also important because unlike on autonomous mode, which you get used to think about forwarding table as a Ceph table, here you won't see OMP routes in the Ceph table. You need to use show SD-WAN IP fib to see the forwarding table of SD-WAN, right? So we are working all together. Ceph table in parallel with SD-WAN forwarding table. It's not two separate instances, just in different parts of the forwarding. If something is missing from the routing or forwarding table, you will step up. Step up is to check the OMP route table. If prefixes are arrived into the OMP table, for whatever reason, maybe it's absent, right? If it's here, but maybe it's invalid, unresolved, so there is a special state for it, U, and unresolved, E and V, then maybe something wrong with the associated TLOC. You need to check the TLOCs. And the same with TLOCs. If TLOC is not resolved, likely there is a data plane problem. And then, okay, maybe you finally found that there is no BFD session with a destination. The basic rule says that there must be a data plane session associated with a TLOC to install the corresponding OMP route into the routing table. If not, well, you need to proceed with your data plane troubleshooting. This is outside of the scope of our session today. Maybe there is a policy, localized policy, right, which is basically a route map, right? Maybe you define a route map as a part of your template and you are filtering out some information, and that's why device is not installing it into the routing table. Also possible. On vSmart, as from a perspective of routing, if we check it already policies, we just verify route table and TLOC table, because vSmart does not care. It does not install into its own routing table information from the OMP table, right? Quick recap of the routing, let's move on. Back to centralized control policies. Again, remind you, 5 steps, right? We check it commit changes, we check it what? We check it peering, we check it which policy in which direction is applicable, and we check it show run part of a config if it is matching to what we defined it on vmanage. Step by step, first step, who read it, when it was done, how it was done, via netconf session. This is apparently the initial configuration, new policy was defined, right? So we checked it. Next step, we check the peering. Nothing special. We just need to ensure that the peer from which we expect route or TLOC announcement to arrive, or to which we expect it to be sent, must be in up state. Obviously, if it is not up, we cannot send anything. This is how you use that support level command. Support level command is not something hidden. It's available. You don't need to do any kind of tricks like service internal or whatever. It's just a support level command, which is very long, mostly used by TAC engineers or those folks, right? So, but the part of it is useful for you because in a couple of lines, it can tell you which policies applied into which direction. It's a bit cryptic because, for example, here you may notice something strange, like what is PFR? PFR is basically like an internal name for application aware routing policy. So PFR is your AAR policy, mem-pol is a VPN membership policy, and control policy is route policy, right? Quite simple. At least data policy is the same name. So when we check the policy definition, show running config, control policy, this is my policy name, right? And a part of that policy, I want to verify maybe there is a site list called branches. I want to see what's within the branches and in which direction it's applied, right? So I'm just double checking the same thing which I have seen here. In the outbound direction, I have my control policy V1, right? When I'm double checking here that I have this policy in the outbound direction. And if I'm interested about some particular building blocks of this policy, I can also check them one by one to see if the definition is accurate. Simple, right? More or less. Step number 5, to test the match conditions and which actions will be executed. Example, right? So this is again my simple policy. I want to know what happens if if announcement is from site ID 40, if routing announce is from site ID 40, and apparently I'm checking if it is a default route, right? 0.0.0.0.0.0/0. And it's again a bit cryptic, but you still can use your common sense to understand what is happening here. We can see that sequence 31 will be triggered, and within that sequence, we are trying to set a preference, apparently, and we are setting some apparently service chaining. So certainly you will look inside in that policy and we'll see what kind of service chaining we use. But again, it's enough to decide and confirm if much is happening accurately or maybe there is something wrong with a policy or how it works, right? We will see more examples in the coming slides about routing-related troubleshooting, certainly. Now let's switch to data and application-aware routing policies. I again remind you, centralized control policies executed by vSmart itself, they can be on inbound direction or outbound direction. Centralized data policies or application-aware routing policies, they use OMP just as a transport. Think about OMP maybe like a BGP protocol, and think that we have yet another address family, and this is address family, use it just as a transport to announce our policies. So that's here we start talking about data and application-aware routing policies. As always, there are some tips and tricks, right? So most important concept when we are talking about application-aware routing policies and data policies is to understand the order of operation. Which policy is preferred over another? Multiple steps, right? And the most important part of this slide is that application-aware routing policy implemented first, but sometimes the decision of application-aware routing policy may be changed by the data policy. This is what's important to remember on this slide, the main point of it, right? Let's maybe have some more practical example. Here's the practical example. I have a branch router and I have a data center. Certainly there is some networks behind it. And I have multiple clouds, right? Multiple colors, hence, right? I have connectivity through MPLS service provider. It's isolated from the internet. And I have this internet circuit. And I also maybe have a backup LTE circuit, which is also part of the internet, obviously. That's why we are connected. And I decided to implement a policy. A simple policy which says that if there is something wrong with voice traffic, I want to have a preferred colors of MPLS, this internet, and then maybe I have to send it via the LTE. What I did? Ooh. Yeah. Practical scenario. What I did, I asked it generative AI, right? I just asked it based on the provided configuration. Can you explain the decision process in a flowchart format and why backup SLA preferred color may not be followed? And also, is it important if this internet is before the MPLS or MPLS is before the this internet in the list? So this is what I got. Do you think it's an accurate description of what is going on here? Raise the hand if you do. Most of you guessed it right. It's completely wrong. Right? Completely wrong. So I have good news for you. You are not getting obsolete because of generative AI. It will certainly help you up to some extent, but still you need to know the basics. You need to know the basics to verify everything. This is not like just a nonsense model. It's a commercial model, and like check it. I don't want and I cannot name it, but it's like a commercial model, not a generic commodity model available for everyone, right? It already was wrong, right? And I'm quite sure it was trained properly. But one more thing, which is important here, that SLA compliance are not checked for backup preferred color, right? It's yet another mistake. So this is not what is done for LTE color. This is the actual workflow. This is the actual workflow. Again, it's for your reference. I'm not going to go through it in details because it's for you, for your later troubleshooting efforts, but it is very detailed workflow on how policy decides what needs to be done. So blue rectangles is a decision point, and orange is what needs to be done, right? Complicated, right? So let's have a bit more practical example based on that actual workflow. So in most deployments, I need to go back to that policy to show it to you, right? So what we are trying to achieve here, we want to send traffic over MPLS or biz internet and use LTE as a backup. Very, very simple. This is what we configured. But in most deployment, more practical use case, more practical configuration will be to define preferred color, MPLS, biz internet, and then backup SLA preferred color to matching to the same set of colors. right? Right. So why? Why? Because the idea here is that if both colors are meeting your SLA, we want to send them over the preferred colors. If we are not meeting your SLA, we still want to send traffic over those colors despite that the service may be degraded. LT, we really want to use only as a backup. That was the original intent, right? That's why we are not defining it, and if both colors are down or unavailable, we will send traffic over the LT, right? That's the only way how to properly define it according to the original scenario. Maybe one more, very quick. There is a relatively new feature, which is called remote preferred color, right? And let's discuss why this remote preferred color may be malfunctioning if you are using very strict keyword. The first important point to mention is that it can coexist certainly with locally preferred color. So if you set that local color is MPLS, and when you set the remote color is BIS Internet, well, it's not usual configuration, but still can be done. They can coexist. We are not mutually exclusive. The second thing to mention is that if you are also using so-called best of worst, which is basically a fallback to best path keyword, right? The intent here is that you will ignore the restrict keyword. Right? Restrict keyword will be simply ignored. It does not mean that your router is malfunctioning according to the workflow on the previous slides, right? It just means that if your intent at the same time to use the best of worst and intent to ignore, you still need to decide what you are going to do, right? And then you will simply use best of worst, not ignore. Yeah. One more important concept, and again, this is for your reference. I know this is like heavily packed with references, but it's important. Important to understand the decision points in between application routing and data policy. Before 20.6, in the ancient ages of Viptela, data policy was overriding application routing completely. Nowadays, it's more intelligent. The guiding principle, if we don't go into details of all of this, the guiding principle just says that data policy will try to take into consideration application routing decision if possible. This is what can be done. So you should remember this part for sure, and if any doubts on how exactly interoperability between data and application routing policy will be, you just follow this workflow and you will understand what is going on here. Right? So, back to troubleshooting. Again, the point is that we recapped the concepts, workflow of how policy decides which path to be taken, workflow which helps you to decide what's the interoperability between data and application routing policy. Now about troubleshooting. And the good news is that we already are aware that first four steps are the same. Just like with centralized control policy, we still need to verify if policy exists, if it is configured. We need to verify that there is no impeding toward the device to which we want to send our application-aware routing or data policy definition. And we want to ensure is it really applied using the support level command. And maybe we want to double-check the policy definition as it is seen on vSmart. Exactly the same. No matter if it is centralized control policy, centralized data policy, or application-aware routing, still the same. The only difference will be to check so-called policy crafting or XML translation. Because the XML is the actual machine-readable format which is, in which the announcement is sent by the smart controller towards the router, right? So this is something new for you. Part of the same command, part of a support OMP command will be the output in an XML format, very long, if your policy is obviously long, which will still be human-readable, but you can use it to double-check if everything is matching to what you define it in show-run output, right? We will see examples, obviously. Once the policy arrived on a router, we will have our own set of steps to be done. So the very first step, just to verify if it is localized policy, less interesting for us, right? It's because vSmart is not involved, but we will check if it is part of a running config. This is for localized policies, ignore it for now. This one is so-called volatile RIB, volatile routing information base for data policies and AAR policies. So show SD-WAN policy from vSmart should be more likely familiar to you already. Next thing which I suggest to do, once you check at it, maybe it's more or less matching to your definition on vSmart, is to check show SD-WAN policy service path or tunnel path, depends on in which direction it is defined. Usually it will be service path, right? And you can use multiple keywords also to verify the policy processing actions. We'll see examples. Step number 3, which I suggest to do, is to sometimes to verify what actually policy is matching to the conditions which you set. And there are multiple options. Always start with something simple. The simplest option is just to configure a counter. It's the additional keyword part of the policy. It's not affecting policy it's not affecting router performance. It's just keep counting packets matching to that policy, right? You can configure that counter and then check that counter if it is increasing. Option B, you can configure a bit more sophisticated thing. You can log packets. But the downside is that it will log only the first initial packet of the flow. So device is flow aware. It's not logging all of the packets. It's not like a debug IP packet on the older routers. It will log only the very first packet from the flow, and it will not log the last packet from the flow, unlike in security policy, right? But still useful for our purpose, for the purpose of policies troubleshooting. Application-aware routing, data policies, right? Last thing, but not least, this is what I call a heavy artillery. We have tools like fiat trace, or also known as a packet trace. It's not the same packet trace, by the way, which you may remember from the CCNA ages, right? It's a tool from the CLI, which is used to trace the packets through the router. Or the younger, but more powerful browser, which is NWPI. We will see examples of it. And up to this point, maybe we verified if everything is matching, maybe still some issues specific to application-aware routing policies, and usually we want to verify if we are matching, not really matching, if we are meeting SLA conditions. So this is how you do it, usually from the CLI. And a few more important commands, we are equally important for data and application-aware routing policies. If you have policy visibility configured, you can check netflow data. Or if you have application visibility enabled, you can also check DPI data. Those both outputs are similar. We will see examples. Next thing, so you see, you probably feel already, right, that we are going down to rabbit hole, right? So we check at everything. Maybe it's once in a blue moon, on a very rare occasion, there is something wrong with the router itself. Usually, at this point, you should already be calling to a TAC. But maybe you want to do it yourself, because you don't trust TAC or whatever. You maybe just for fun or fake profit. And this is, by the way, my cat trying to put himself into my shoes and find a bug like a mice, right? This is an old VH router, by the way. And cat is very famous in Belgium. He is a national winner and world champion according to World Cat Federation, by the way. So, what needs to be done then? But before we move on to that rabbit hole of policies troubleshooting on the device itself, let's have some examples and see how to use the commands mentioned on the previous slides. We are not covering, again, the vSmart part, because vSmart we have checked, I remind you, no difference between data policies, application-aware routing policies, and control policies from a perspective of vSmart, how we troubleshoot it, right? The only difference will be policy crafting. And since I mentioned already third time, the show support level command is very long, we want to use proper filters, so we see only the relevant part. To see the relevant part about the XML crafting, I suggest to use the keyword begin, policy received, then until section statistics, and this is what you will see for the relatively simple policy of DIA, right? Next step, policy arrived. We hope that it is arrived on device. What do we do on the device? Show SD-WAN policy from vSmart. Raise the hand who use it regularly. Most of you who are dealing with policy. Okay, this is very well known for you, but this is only on the top of the iceberg, right? This is only the top of the iceberg. Raise the hand who are aware about this command already and used it before this session. So this is the next bit lower. The top part of the iceberg, I will say. Not the top, but high part of the iceberg. The command which will help us to verify the policy decision. Let's say I can specify which is the source IP, which is the destination IP, my protocol is UDP, and I want to know what happens with traffic towards port 53. And it will tell me that I will send it to a remote next hop interface and blah, blah, blah. Not very interesting, right? But what you need to pay attention to is if you see this keyword. This means something bad happened. If you don't expect this traffic to be dropped, and you see at the same keyword black hole, it means the traffic will be dropped, right? Again, not very helpful, right? We thought the same. And that's why in 1718, we decided that this command needs to be enhanced. And for example, I have a policy. Again, I'm using remote preferred color. Where is it? I cannot see. It's like a SSLA class preferred color MPLS. Remote preference, yes, remote preferred color MPLS. And then I want to restrict it to a remote color of MPLS always. And in my case, I'm not meeting that SLA, and you see what is going on. The new version tells us precisely not only which policy is applicable to that traffic, not only the VPN list and the sequence number matching to that, which this traffic is matching to, but also the reason, detailed reason why traffic will be dropped, not just black hole. Again, 1718, it's already available now. It's not yet the Golden Star recommended release, but you can already start training and using it to familiarize yourself with a new tool, right? No, not a new tool, with enhanced tool. Back on track. Remember, first step to ensure that the policy match actually happens, and how to use it. Quick examples: counter. You define a counter, how to check the counter. We send some traffic. If we enter show SD-WAN policy, data policy filter, it will tell us how many packets were matching to that policy. Similar one, log action, right? We configured log action, we attempted to some traffic, maybe SSH here, and as you can see in the logs, there will be a log saying that which policy we match it, which sequence and result. Already a bit more useful, right? Bit more heavy stuff. And let's have some examples of packet trace. First of all, how to use it. It has minimal impact on the router performance, maybe 1 or 2% of performance, if you define conditions for the tracing properly. So first of all, you need to define conditions and say, I want to know more about the traffic towards from specific source or towards specific destination. This is how you can do it. You can do it in line, or you can define an access list with more complicated match conditions. And then you need to say to the tool how many packets you want to trace, because we don't want to trace indefinitely. Maximum number of packets you may trace at once is 8,192, and then this is how you start it, right? If you want to see if you want to also to have something similar to packet dump, you can also dump packets in the hex format. And sometimes it may be useful not to trace packets which are sent successfully, but rather if you suspect that router is dropping something for whatever reason, and you want to understand why, maybe because of a policy, you can check the specific drop counters, and maybe enable drop counter for the policy specifically as SD-WAN data policy drop, right? It will have an ID of 483 for this version, so you can use trace on per drop code ID. Very useful. Not essentially per filter, per IP address, but also you probably can trace whole packets dropped by the policy. So maybe you started it, and then you want to check if you're really capturing anything. This is the statistics overview. It will tell you how many packets were dropped, how many forwarded, and match it to your trace conditions. Then you can stop it manually and clear all conditions, right? To show the captured packets, the list of captured packets, you use the summary keyword. And by the way, I want to draw your attention to this packet. It was dropped with some special drop code. Drop code, no stats update. If you ever see such a drop code, it means that the drop code was valid. So if the drop code is no stats update, it means that the router decided not to update its own statistics because it's unnecessary, like excessive. And if you're really interested, this is basically a BFD packet. BFD echo packet which returned back to us. We don't want to count our own returned BFD packets. There are other places in the software where we count sent and transmitted BFD packets. That's why here, as a part of a data plane, we don't count them. Right? And details of specific packet, maybe we want to see inside of this packet, which the source, IP, destination, which features are applicable to it. You will use show, platform, packet trace, packet output, right? And this is the example on how it looks like. Again, a bit cryptic, complicated, I admit it, but once you get used to it, it is a very powerful tool, very important tool, which will tell you also what exactly happened with this traffic. So, for example, I have a feature SD-WAN access list, and it will tell you which sequence number we hit and which action actually was applied to it. This is localized policy, by the way, right? Localized policy to set the quality of service, apparently. It will tell us that we set a forwarding class and precedence accordingly, right? Bit down the line, bit down the output, there will be also information about application-aware routing policies. In this case, apparently we are not yet classified it accordingly, and we don't know which application it is, and hence we are using all available tunnels to send the traffic, and it happened that due to hash algorithm, it was just sent to the biz internet. And finally, on the output direction, you remember maybe that on interface we have multiple queues, and depending on the configured forwarding class, we will set that traffic into a specific queue. This is what is happening here. You also see it in details. So your router is like under a magnificent glass. You can see everything step by step, which is going on with the traffic, right? This is finally we are encrypting it because apparently the encapsulation is IPsec, and we will be sending it out of a Gigabit Ethernet 3 interface. Complicated, complicated, but let's have a bit more practical example. So maybe you captured a summary, just a few packets. And this is something interesting happens here, because we definitely know that Gigabit Ethernet 1 is our outside interface, which belongs to MPLS color, which belongs to MPLS connection. But then at some point in time, for whatever reason, we send the same traffic through the biz internet. So let's try to figure it out with help of packet trace. If we check the very first packet, which is packet number 0, there is something interesting happens in the DPI and bar section. It will tell us that the very first packet we cannot classify yet. And this is very common. This is very common with DPI classification. Most of applications nowadays we are encrypted, and it's not enough to see only one packet sent towards the port 443 to understand which actual web application, for example, it is. The same may happen with SSH. Maybe somebody enables service running on the port 22. It does not mean essentially it's an SSH, unfortunately, right? And the same we can see here. So application-aware data policy cannot match based on the application yet, and that's why it is sending it across all tunnels. It does not mean that the router misbehaves. It's already shown to you here. So there is no match to the application. That's why we are selecting whole tunnels, right? And it just happened that back then, the very first packet was seen according to the hash algorithm. We were sending it over the MPLS. But let's check the packet number 4, right? So this is the packet when we first time have seen that the state has changed, and we sent it through the biz internet color. At this step, we finally managed to recognize that this is the flow which belongs to SSH, right? And DPI classification has been completed, and I have an application-aware routing policy which finally can match based on the traffic. I have a sequence 10, and the requested SLA was to comply with SLA defined as test 1, and actual color will be sent to biz internet. Voila, myth, not myth, like mystery debusted, right? We now understand what is going on and why the other interface was selected. And WPI. As I said, this is the younger brother, but more powerful brother of packet trace. I can also sometimes refer to it as a packet trace on steroids. So it's a tool which is utilizing partially the code of packet trace, but you can run it across multiple routers at the same time. Right? If with packet trace, if you need to trace the flow across the multiple routers in your overlay, you need it one by one. You need to configure it one by one. It's not very convenient, not very easy to do sometimes, right? And WPI will do it, will kind of automate it for you, and will do it one by one. Oh, all at once, all at once. How it works in details, at the end of my session, there are references to other sessions of my colleagues who are explaining how NWPI works, but our main purpose is to understand how NWPI can help us with policies troubleshooting, right? So, just like with packet trace, we define some conditions. Maybe I want to know what happens with 10.10.1.10 IP address. If you have been to my lab today, or plan to attend to my lab tomorrow, maybe you recognize this IP address already, or will recognize it tomorrow. This is one of the hosts. And site 300, I want to know what happens when I send traffic towards that IP address. I just need to click start. I'm sorry. When the next page will appear. As you can see, This is already giving us some interesting information, right? I can clearly see that here is an SLA violation happens. It means that I have application-aware routing policy, and traffic does not comply with required application-aware routing policy SLA class, and we are doing something. It's not yet clear what exactly we are doing, but this is already clear that application-aware routing SLA violation occurs. So we don't need to go into the CLI, we don't need to check that AAR statistics and so on, it already will tell us. This is, by the way, 2018. Right? In the older versions, the functionality of WPI is rich, but it's not rich as in the recent versions, right? And I promised you to show the latest advancements in troubleshooting tools. This is one of them. So then, the useful thing for our purpose, there are two buttons, show up route policy and show data policy. If you click them, the next page will appear. For example, we can see already what is our policy, how it is defined on the device. Again, you don't need to go into the CLI. It's everything in front of you already. We can see that some application-aware routing policy defined, right? If you scroll down the page, maybe you close it that previous pop-up window. If you scroll down the page, there will be so-called active flows tab and completed flows. Depending if flow is still running or if it is already finished, you can find it either here or here, right? And if you scroll down even further, there will be a section called Inside Advanced View. It should be already more or less familiar to you, right? Looks very similar to packet trace output, right? So it will tell you which data policy applicable here, which in-bar classification happens and why. And what's more important to mention, and WPI is not tracing all packets, but it's tracing the most critical. No, actually I have to be accurate with what I say. It actually traces all packets, but it keeps statistics about only the most important packets. And the most important packets are the very first packet in the flow, the packet when the DPI classification finally done, and the very last packet in the flow. Sometimes, like in this example, we were lucky enough because apparently the SSH session was already in the cache of nbar, so we classified it from the very first packet. That's why in the drop-down list there are no multiple choices. But in this drop-down list, usually you will see the first packet and DPI done packet, not more. That's why you can capture a lot of packets, right? Because you don't need to store all thousands of packets, only most critical ones. Yeah. If you click on that link inside view, you will end up on the one more interesting page, which is again something new in 2018. It will tell us a lot of details about policies and what is going on. For example, it will give you a detailed readout about application-aware routing policy and tell us why we are having packet loss and why SLA violation occurs here, right? And actionable insights about that policy. One more useful thing is the routing insights tab, right next to it. You click on the routing insights tab, it will tell you like a flow chart saying what is going on here, what policy, who exactly making an influence on the path and what is going on here. Do you guys see any problems with this output, by the way? No? Raise your hand if you do. And I'm actually glad to see that nobody recognized the problem here. The problem here, and this is what you definitely will learn today, there is only one candidate path, right? And for application-aware routing policy, usually you must have at least 2 ECMP paths, right? Out of which you decide to which you must follow. Here it's like very artificial example. We have only one path, and obviously application-aware routing policy cannot influence anything. It's only one path. It's like a typical problem with policies, application-aware routing policies. You try to influence some path, and maybe this path is already out of consideration because it's influenced by centralized control policy. Maybe you set a preference. If you did it, you basically have no choice, and application-aware routing policy will send it always over the color which experiencing some packet loss, right? This is exactly what is going on here in my example. Okay, let's move on. So, enough about heavy stuff, packet trace. You remember there was a section like simple things which we still can verify in the CLI. This one should be aware to you. Just maybe one less common thing is that you can apply detailed selection of the traffic for the application routing policy statistics and see per color basis and per destination system IP what is exactly going on about it. So you don't need to read the very long output of all SLA stats, right? We always use modifiers. Check, define the local color, remote color, and the system IP. This is how CFlow flow data looks like. Not the difference, right? There is no application recognize it. And I promise it that I already said that it's very similar to APP-FWD DPI data. The difference will be that if you enable flow visibility, the only difference will be that here we will see obvious applications. So both commands are kind of interchangeable, depending on what you have enabled. Step number 5. And if you're ready to go down the rabbit hole, let's do it, but very quickly, right? Because we are running out of time. But again, I need 10 additional minutes, and I will really appreciate if you stay with me for 10 more minutes. I really want to convey this message to you today, to finish it, right? So we are going down the rabbit hole, and this is, by the way, not a stock photo, but from Digim. Digim, it's a small village near Brussels, where the Cisco office in Belgium located. It's an actual rabbit hole. Sometimes rabbits are digging, hitting, like doing crazy stuff. So, centralized control policy troubleshooting on iOS XE routers. But before we do so, again, as always, as you probably already get used to, I need to introduce some basics. Quick recap. So, all routers, all Cisco routers consist of two major parts: the control plane, or RP. RP is important, the keyword RP, because it's part of CLI commands, and data plane, which is QFP. Again, very important because this is the keyword which we use on our CLI commands. If you're interested about a bit more details, this is how the RP part looks like, and multiple processes running here. Not yet interesting for us what exactly those processes are. And the QFP part, what is important here is that it can be implemented in different ways. It can be a dedicated CPU handling the data traffic. It can be just a software process like for Catalyst 8000V. But the good news is that you basically troubleshoot all platforms running iOS XE in a similar way, including policies. So you don't need to know the platform's specifics to troubleshoot your policies. So what is important here is what are the processes which are implementing policies. And this is the set of SD-WAN daemons or system processes which are involved into policy programming to the data plane, right? So again, we don't need to know in details how it works. We just need to know which part of the software you need to make a checkbox, right? To tick the checkbox. I check it here, I check it here, I check it here, I check it here. This is what you will do. And we will have examples, right? Here, why I mentioned vDaemon, some of you may be aware that the vDaemon is the process responsible for control connections, because control connections is the transport for the OMP protocol, right? So it will establish control connection just like any transit traffic. Let's imagine there is a transit traffic. Here it's like a bit different path for it, but it still be processed the exact similar way. There will be no traffic initiated directly from RP somewhere. It will always pass through a forwarding plane, right? When it will somehow, through all of the from features implemented in the data plane, arrive to the smart controller, TCP connection will be established, right? And then finally, we want maybe to establish, here we want to establish TCP connection. So from vDaemon, we will, not from vDaemon, from OMP, we will initiate TCP SYN to establish an OMP connection. It will send the traffic. It will send the traffic towards the vDaemon. vDaemon will encrypt it. It will send it to the smart controller. The smart will send SYN ACK and so on. So there will be a TCP session established, right? We're more or less ready to exchange the policies. OMP peering established, we verified it also, maybe we show OMP peering system IP, and when the policies arrive, how actually policies processed through the device. First of all, policies processed not by all of those daemons. First of all, we are processed as a traffic itself, right? As a traffic. So traffic flows, it goes to vDaemon unencrypts it, unencrypts the packet, right? And then it will send it to the OMPD daemon. Going down rabbit hole, OMP daemon will unpack this packet, and it will see that it's like an XML formatting. It will pass it down to so-called confd daemon. Get another daemon. You don't need to worry about what it is doing. It's doing its stuff, and then it will send it to FPMD daemon. We just need to check it step by step using our common sense that policy looks more or less the same while it is having all of the permutations while going through all of the different daemons, right? Then FPMD will send it to forwarding manager. Forwarding manager has also two parts. One of them is just a transparent part. This one is just building relationships in between them. And then the data plane. And in the data plane, we have also a set of commands to verify it. So far, it may be not making sense, but we will have some examples in the coming slides. What is most important key parts of all previous, not all, previous slides about routing, control plane, and data plane. First of all platforms, they are using the same architecture, similar architecture. The second thing is that there is an RP, which is route processor, implementing the control plane. It's running Linux kernel and multiple processes handling the policies and control plane, which is basically implementing the control plane in, which is implementing policies in the control plane. The data plane, known as a quantum flow processor, QFP, the abbreviation is which we use for the forwarding plane. It's implemented as a dedicated line card, CPU, or even in the software. Does not matter for us. And all features are implemented as a feature invocation array. If you remember when we were talking about the packet trace, there were like features. Features, every feature, like data policy is a feature, forwarding is a feature, application-aware routing is a feature, and so on. So features invocation array. This is like a set of steps which we need to execute while traffic passing through the data plane, right? So the application-aware routing or data policies, they arrive as an OMP update, they run packet, send through all of those multiple processes from RP towards the data plane and program it on the data plane. The good news, we use the same troubleshooting tools, as I said, and techniques on all of the platforms, right? So back on track. It's a quick review of a platform. If you want to know more about the platforms and the architecture, at the end of my session, there is also a reference to one of the sessions, one of my brilliant colleagues, Olivier, who are together with Fred, talking about platform architecture. You can definitely benefit from watching it. So, policy programming on a router. First of all, question why? Why should we do it? Likely you don't. But if you really want to have fun, if you want to put yourself into the shoes of TAC engineer, which maybe once in a blue moon wants to troubleshoot it, and maybe, again, it's like very rare occasion, unlikely you will not ever see it, in the log messages something like this appeared, like I am stuck, like mumbo jumbo, right? Nothing, it's not clear what is going on here. You need to remember only few concepts to continue that kind of fun. First of all, that there is a thing which is called asynchronous object manager. It's just yet another mechanism which helps to continue router with processing of policies while other daemons are waiting to complete the programming of a policy. Right? The state of this AOM can be done, which is good for us, or if you see it is in the pending state, this is a bad state, obviously. Right? Nothing special so far. The next thing you need to know is that, I don't know for whatever reason, but we keep naming the things internally one way, and then externally it's named a different way. So here, the class group is actually a policy, and the class itself is a policy sequence. Kind of making sense, right? Just remember, I will be using for the course of next couple of slides those terms interchangeably. So again, class group is a policy itself, the whole set of sequences, and one sequence is just a class. And the whole policy should be programmed from OMP, as we already probably realized it, via the forwarding manager, via a forwarding policy manager daemon towards the forwarding manager, and then to the data plane. And there is one more daemon which is kind of useless, is RP, not really useless, but we don't check anything because it's transparent. It's just a transport in between FPMD and the FMAN. For the sake of demonstration, again, I will use a very simple policy. Even with such a policy, I know it will be confusing. So this is DIA policy. I want to ensure that all traffic sourced from the line, from some particular prefix, 10.10.10.0/24, is just sent to the DIA. And if not, it will be dropped. That's it. Only two sequences, basically. Sequence 1 and the default sequence, obviously. So let's take a look how it looks like. First of all, you will verify, if you remember the set of diamonds, you will verify FPMD, as it looks like from FPMD view. Kind of cryptic, but still, if you use common sense, you will see that there is a default action and there is a list of conditions, match condition, we match based on prefix, we perform some actions, right? So still making sense. That way you can verify. The only thing which may not be clear, what is the default action 1? Action 1 is for drop, and action 2 is for accept. At the end of a policy, we had a default action of drop, if you remember. Next thing, so we check at FPMD, and if OMP-related output from FPMD has some issues already, maybe you notice that there is some discrepancy, then it's a good idea at this point to start debugging something, right? Debugging something and hope to see the reason for this, because sometimes in the logs it's very obvious, like the router will start crying and saying, oh, I cannot program this policy because this is missing and it's incomplete, I will just skip it, right? So how to do it? Just like with the smart controller, if you remember, there is a difference on per version. Same on iOS XE. Before 17.10, some of you may be still using 17.9. You need to enable debug for OMP is like debug platform software, blah, 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 OMP policy level high. Starting from 17.10, you need to set the trace level. And this is what you do on 17.10. Then usually you will clear your OMP session just to ensure that the vSmart resets the session and try to send the policy again, right? And then no matter which version you use, you will check OMPD and FPMD logging. Sometimes it may be already helpful because those logs may tell you why policy is not programmed. Sometimes certainly it's not, but once in a blue moon it may be helpful. If no failures observed here, if no error messages like ERR, likely everything went fine, and the next step, it was successfully sent to a configuration database. So, configuration database, okay, we verified it according to the debug. If nothing happens, it's all fine. We will start checking the forwarding manager, finally, right? And to check it from the forwarding manager, we need, first of all, to find the corresponding class group, right? ID. Basically, everything is per ID basis. We will verify class group or policy ID. And then we will verify the so-called notorious A or M status. In this case, it is done. Right? Done is a good state. Done is everything all right. But you need to remember that your VRF name, which is a number, not always corresponds to the ID. Like in my example here, I have a VRF1 defined, which has an ID of 3. Right? That's why you need to find the matching VRF ID towards your VRF name of 1 to debug the policies further. Remember this number because in upcoming slides we will use that ID of 3. Right? Again, VPN name is 1, but the ID for this VPN 1 is 3 actually. Right? It is very common because there are some internally defined VRF IDs which may occupy ID of 0 and 1 before you define VRF 1. Service-side VPN, right? So what's the next? The next step will be to find all classes or sequences for the corresponding policy, or again, class group, right? So to do so, you will execute summary. In this case, we are lucky because we have very short policy, only 2 sequences, and within that class group, within that policy number 1, we have class, again, or sequence of 1, and the other one is 65.535, which is a default, which is the last one always. It also implies that you cannot have a policy with more than 65K sequences, right? Because this is the maximum number on per policy, one of the limiting factors. So this is the real life example of what can go wrong already. I will say not really like common, but we have seen it. We have seen it that maybe you have some match based on the application, and then you cannot program that application-based match. There will be only one sequence in the list. You will see only 65.535. It means something already went wrong. And this is specifically when we manage SDIVC container has not sent the definition for the application yet, maybe, right? So maybe you just need to wait, and then the policy will be programmed. The next step, knowing that class group, we can see all of the details and programming in that forwarding manager, and we should be more or less similar to what you see in the show SD-WAN policy from vSmart output. Again, use your common sense and then check everywhere if the status is done. If status is done, it's okay. It's like okay status. Right? Let's move on. One more thing which is useful for our troubleshooting purpose, maybe the policy was programmed properly, but maybe the match conditions were misprogrammed. Maybe you had a prefix of 10.10.10.0/24, but somehow it's got programmed as a 10.10.10.0/32, right? How to verify it? You have an object, and this object has an ID value, yet another number, right? Then we will use that number to verify the programming if it was correctly put into the data plane. This is yet another good status. If PD created means that the protocol data is created and everything is programmed. Or maybe if you have a short policy, you can see all of them and verify all at once. You don't need to know the ID then, you just use the all keyword and there will be a list given of all objects which you use in your policy on a device, right? Phew, enough about control plane, right? Now we are at the QFP, at the data plane level. But here the things are kind of similar. There's also like an identifiers which we use, and those identifiers we will use to verify if everything is programmed correctly. So we will, first of all, we will ensure that as a part of the interface, if it is, in my case, it's application aware routing policy or data policy, you will see such a name as SD-WAN_policy FIA. It means that the policy actually was enabled on the interface as a feature. Because policy is also, remember, this is feature which is enabled in the QFP. One of the features, just like the quality of service, just like an encryption, just like as anything, right? So it was enabled under the interface level. This is how we verified it. Feature is enabled. If it was a localized policy, maybe we will see something different like SD-WAN ACL. Again, this is how localized policy name it, access list. If we want to verify localized policy, yet another identifier which may be needed for us is the so-called interface handler ID. And this is how you can find it based on the interface on which the policy applied. But we are troubleshooting application-aware routing policy or data policy which is applied on per VRF basis. On per VRF basis, we want to know this notorious VRF ID, right? So since we have only one policy, and we are lucky enough, we have only one policy, and the number is 1, right? For simplicity, if we use that identifier, we can see the match conditions. The interesting thing about the data plane is that in the data plane, the match conditions and the actions are stored separately, and we verify them separately, right? It's not like in the control plane when there is one set of sequences in the same sequence with match condition and action condition programmed all together. Here, we will be stored separately. That's why we verify them also separately. But what is common in between control and data plane is that we still can use object identifiers to verify individual objects here, right? And we see in this case, again, I'm using here to check what's within that match condition to ensure that there is maybe no misprogramming if a prefix is still set correctly. You remember it was 10.10.0/24, and indeed, everything programmed correctly so far. This is the second part, the actions. So this is how you verify actions. Again, you are using the identifier of your policy class group, and then there will be sequence, you see no match conditions, but only actions. This is how it is stored in the data plane. Or maybe you can verify on per sequence basis. If your policy is long enough, you don't need to scan it one by one. You just specify the policy ID and the sequence number, which is a class. Again, it's kind of lucky that we have only short policies, only one sequence and only one policy. Both we have an identifier of one. And it will show us what is happening here, what actions are happening in sequence 1. Based on QFP class group or policy ID, we can, if we already check it and found interface handler, right, we can check the details how the policy programmed in the TCAM. And I keep forgetting what TCAM is, so I decided it's a good idea, not for you, for myself, to include this as a reference with definition of what is ternary content addressable memory. Right? So, again, cryptic, complex, but still, if you use your common sense, you can understand more or less what is going on in the TCAM. And in the TCAM, the valuable information, first of all, how many entries are available, how many memory we utilize in the TCAM, how many classes we have. So basically, you need to verify if we have both, or if you have only one sequence, that you have two classes, your sequence and the default class. If you have 100, you need to have number of 101 here, right? And what is also possible to verify is the result. So the sequence 1 will be 01, and the default sequence will be 65535, just like in the control plane, which is represented in the hex format as quad F. Well, not a lot of you can get out of it, right? But still, up to this point, there are a few more last resort options. And what is last resort option? As you get used to already, probably, it's some debugs. So you need to enable some debugs. And those are the debugs, how to use them in the most efficient way. You set the marker. Marker is like a position in the logs from which we want to trace everything, we want to log everything. So we set that marker, we enable QFP, remember this keyword already, right? QFP active feature SD-WAN data path policy. So a tracing of a policy as it is programmed in the data plane. Maybe some misprogramming happens and a router already crying, oh, I cannot do it because of that and that, right? And one more thing is SD-WAN data path. This is for data policy, right? When you initiate some traffic and once you're happy and traffic was sent, you stop the policy because it's very chatty, and then you disable the tracing, right? How to see the logs? Just like with OMP, maybe you remember it, right? A show login process, this is yet another name for QFP. Internal, start, marker, and starting from your marker which you have defined here. Well, what if still something not clear? What to do next? What will be your next step, right? There is always a possibility for the next step. I have no better advice, unfortunately, right? Okay, if you are not right till now, if you're still with me, if you have not left, again, I really appreciate you being with me. And it's time for part number 2. Let's apply our knowledge on practice. If you don't look like my cat, now, so let's go on. I have 2 subsections here. First one I call not so well-known failures or problems with centralized control policies. And for sake of a demonstration, again, I need to remind some concepts. The concept, what is disjoint underlay? Who knows what is disjoint underlay? I think basically you all know already based on that slide, right? So the disjoint underlay is the connectivity topology when 2 devices are not connected with each other directly. Like here, isolated MPLS, not connected to the internet, but it's connected to some gateway which has connectivity to both. This is called disjoint underlay. And some interesting issues are always happening in such underlays. And the case number 1, which we will be discussing today, is the active standby redundancy, which is not working properly in such an overlay. So the main objective here was to ensure the preference towards the data center is through the gateway 1, for whatever reason. Maybe more powerful router, I don't know. So how it was implemented, the preference was set, the higher preference was set on announcement from gateway 1 to vSmart, and the lower preference from gateway 2, right? The OMP preference for the route. It can be also the same problem may arise if someone tried to mess up with a service-side routing and maybe influence path decision based on the service-side protocol metrics. Like, for example, OSPF. Yes, OSPF metric, it's a good example. What happens? So this is the policy which was put in place to implement such a preference, right? We just match the route. If it is advertised from site ID of a data center, we set a preference of 200, and looks simple enough. Do you see any potential problems here already? And again, oh, I like it. So I'm sorry you are not learning anything new, probably, but the rest of you, and I'm happy to see it, that apparently you will be learning something. Let's discuss, but first, let's see some of the outputs. So this is during the normal state, right? So when there is all links are up, everything is fine. Apparently, we are selecting MPLS, and this is the system IP of gateway 1. Apparently, we will be installing it as a preferred path. So far, it looks good, right? But what happens if there is some issues with uplink towards the MPLS from gateway 1? Ooh, that's a problem, right? We cannot install any route into the routing and forwarding table because in the OMP, we cannot resolve them. Remember that quick recap on the routing troubleshooting, right? This is a bad state. If something is invalid and unresolved, it means we cannot install it into the routing state. And if we follow further the troubleshooting of routing, the workflow of routing troubleshooting, we will also find that basically there is no data plane between gateway 1 and obviously because there is no bis-internet connectivity, right? That's the reason. That's why BFD session cannot be established. So everything makes sense so far, but it means that there is misconfiguration with the policy. And we need to understand the logic of a policy to resolve this. So let's have a graphical representation of what policy do. Both gateways, they announce the same prefix, right? With 2 different TLOCs. Then the action on inbound direction will be to set the preference. right? And we will set preference 200 for gateway 1, for this guy. But then, this one is disconnected. Uplink of the gateway 1 towards the MPLS disconnected. Still, the smart controller, which is not aware about the topology as such, will perform best path selection, and it will send only best paths. And from the perspective of the smart controller, this one is the best, right? With internet. It means that branch 1, it has no valid paths to establish the data plane. There is no biz internet color on BR1, just because the policy applied in the wrong direction. So the better way of doing this will be to apply the policy in the outbound direction, right? Allow the smart to calculate the best path from the perspective of the smart. Both paths, MPLS and biz internet over the gateway 1 will be equal. It will consider both for the outbound policy, and then, with help of outbound policy, we already can set preference. So the policy itself remains the same. It's just a matter of a policy direction, right? Here, just testing. Quick verification if we are right or wrong. So we are checking the output. We can see that during the normal conditions, MPLS is preferred. But if MPLS is disconnected, we can see despite that the preference is set for the biz internet, right? Which would result in the best path selection on vSmart. Here we allow branch 1 to decide what's to be selected. Since even if it is preference is better, since it is unresolved, according to AMP best path selection algorithm, we will not consider it for best path and we will select whatever is available. MPLS is the only choice and the connectivity will be preserved, right? So far, so good. Any questions about this case? Case number 1? Good, because we are running out of time. Case number 2, this is the case, very common one, and if you have been to my lab, you already have seen it. If you plan to visit me tomorrow, pay attention to it, because we have one of the cases exactly about set TLOC list. And the idea here is that we have a data center. In the data center, we have, again, 2 uplinks per router, and we want to ensure that we always forward the path over the gateway 1, and we prefer MPLS of gateway 1, right? If gateway 1 MPLS are not available, we want to follow MPLS through gateway 2. And only then we select biz internet of gateway 1, and the last resort is the biz internet of gateway 2. So to implement this, the policy was put into place. Do you see any issues with this policy? No? Okay, again, I'm glad. You're either sleeping and don't want to raise a hand, or it's something new for you, which is good. So the problem is, let's test first of all. Let's test first of all and see what is going on. So again, I'm using the show SD-WAN OMP routes output, and during the normal state, everything looks fine, right? So we prefer, this is system IP of gateway 1, and we prefer MPLS. So far, so good. I'm also checking with help of show SD-WAN policy service path just to double check and demonstrate that this command can be used quite successfully. And then this is not very familiar for you, but the idea is that if we use the resolve keyword, it will tell us which exact next hop will be used for this path from a server side VRF. So we just verified that gateway 1 is preferred, right? But now let's break it. How to break it? On the service side. On the server side of VRF3, there is an interface, gigabit Ethernet 4, I just shut it down. It's not an uplink, it's this interface towards the service side. And if I check routings now, there is no valid route. So route is not installed into a routing table. So it means basically that if any traffic arrives on the gateway 1, it should be black-holed, right? Because gateway 1 itself has no connectivity to the service side. And this is exactly what will be happening. But if you check on the vSmart, for whatever reason, and I can tell you in advance already, it's not vSmart who is guilty here. vSmart is doing what it is supposed to do. vSmart keep advertising. vSmart has paths towards the gateway 2, but if we check on the branch router, we will see that we're still sending traffic towards the router 1, towards the gateway 1, right? Where it will be black-holed. And obviously, if we test connectivity, the destination is unreachable, right? And this is because somehow we are still selecting, according to the OMP, we are still selecting gateway 1 color MPLS with preference 300. Maybe it's OMP broken on branch 1. We will see. And if we check vSmart policy, vSmart is doing, as I said, what it is supposed to do. vSmart is not misbehaving here. It's instructed to set a TLOC preference with set of TLOCs.
And it will do. It will do so. The output command is a bit tricky, but I'll tell you what is going on here. We don't want it to paginate. It's basically like on iOS to set the terminal length of 0. Then we want to exclude all unimportant attributes, which are not set. And we want to know information only about branch 1. So what exactly we smart advertise it to the branch 1? Branch 1 has system IP 11, right? .1 for gateway 1, 11 for branch 1. And we see that something interesting happens. We have 4 paths. Each path has the same originator, but despite that third path has the originator of gateway 2, we smart set a TLOC of gateway 1, right? It's again logical mistake. Logical mistake, and this is, I remind you what the original policy is, right? We set the TLOC list. In the TLOC list, we decided to follow a shortcut, a simple path. We just set a list of preferences. And this is what is going on from a graphical point of view, graphical representation of a situation. So gateway 1 disconnected. Gateway 1 cannot advertise default route anymore, right? Because there is no service-side connectivity. The only announcement which arrives to vSmart is from gateway 2, but gateway 2 is still doing what it is supposed to do. It is making the set TLOC list. In the TLOC list, we have a long list with all of the TLOCs, right? And again, it's just a logical mistake. If you understand what vSmart is supposed to do, you will instantly realize that no, it's not vSmart guilty, it's a misconfiguration. The better way of solving this, achieving this, will be to perform a match based on TLOC, and only then set a TLOC with preference. So basically, you break down your TLOC list consisting of 4 TLOCs into 4 different sequences. Sequence 1, sequence 2, sequence 3, sequence 4. In every sequence, you will be matching based on the TLOC and setting a new TLOC. This is how we did it. Or you can probably join it on per router basis with only 2 sequences. But still, you need to break it into 2 different sequences. Otherwise, the problem here will continue to be happening, right? Just a testing, quick testing, verification that we are right. And yeah, it works as expected, even if the service side is disconnected. This is a real TAC case from 2019, but still relevant today. Okay, case number 3. Very quickly, we have now joint underlay, right? So we have connectivity to the common color, which is BIS Internet. And again, I apologize. I just need 5 minutes of your time to finish, and you will definitely benefit from this knowledge. I'm the only who is holding you from the celebration. Sorry, and thank you. So the idea is here that we send the traffic through the intermediate destination. This is the preferred path. Despite that the direct path available between branch 1 and branch 2, we want to send it through a DC1. To implement this, the policy was configured. The policy is something interesting happening here. We are using the keyword called TLOC action primary, and then we set the 10.0.0.1, which is DC1, as a TLOC here for the TLOC action primary. If we check the trace route, right away after we apply it with policy, we will see that apparently it's not taking place. It's not doing what it is supposed to do. The traffic is sent directly to branch 2. And if we check show SD-WAN policy service path, like suggested to do according to the workflow, you will also see that it's sent directly to the branch 2. It's not like the trace route output only issue. It's indeed confirmed by multiple commands. So what's the next step? Usually you will verify your policy, you will ensure that the policy functioning correctly, but then you fall back to the routing troubleshooting, and you will check show SD-WAN route here, right? You will notice that it is unresolved for whatever reason, and something interesting happening here. One of the attributes will be kind of unusual. This is ultimate TLOC. So the ultimate TLOC is a concept which says that the ultimate TLOC is a concept. This is the target TLOC, which must be used by the intermediate hop when the traffic is being sent towards that router, towards that destination, right? So it's to establish the ultimate data plane to it. This is unfortunately an example of a problem which you won't be able to fix just by looking into the outputs, right? Actually, you can if you see already that it is unresolved here, it's already like a red flag to you. But why it is unresolved, it's not very clear, right, from the first glance. And unfortunately, this is kind of a problem which you need to be aware already. And the rule says, there is a rule. If you want to use TLOC action, you need to enable special service, like a service chaining, but it's not about service chaining, which is also confusing. The service called traffic engineering, right? You can define it either like a CLI add-on template, or in the template, you can also enable it as a service. And to add complexity, as I said, it's not like a usual service. It will not be seen as a part of show SD-WAN OMP services output. Why? Because in reality, yeah, by the way, it's also prerequisite for on-demand tunnels, the service traffic engineering. I intentionally not discussing on-demand tunnels here because it will take additional 10 minutes, but this is equally applicable for on-demand tunnel situation, with the only difference that on-demand tunnels will use a backup action keyword, TLOC action backup. The idea is here that if we are testing that solution when we enabled TE, everything will be working right away. So we will be able to resolve it just as expected. But why? You may ask me why and how it works under the hood. Why service TE is not seen as a part of show SD-WAN OMP services? Because this is rather a configuration stanza, configuration knob. Configuration knob which will enable so-called link routes advertisement. Link route can be also checked with help of some tricky internal command, but it's not something hidden. You can actually verify it. It will instruct the intermediate router, unknowns its own BFD states towards the all routers in the overlay. So the other routers in the overlay can double check if you have data plane towards the final destination. This is how it works under the hood. This is the actual reason why, if traffic engineering is not enabled, router 1 is not aware about the situation of intermediate router, and it cannot resolve the route, right? Now you know. Now it makes sense, I hope. Now it should start making sense. If traffic engineering is not enabled, there are no link routes. This one is interesting. This one is interesting because, again, this is quite recent. Maybe a couple of years ago, we had a situation when the big network was designed with multiple data centers, and guys are testing it. We reloaded in router, and the symptom is that the hub router was reloaded to perform a software upgrade, right? And after the upgrade, device cannot install any policies. So we instantly thought, what? It's a software defect, maybe. Again, we are doing something, your software is faulty. It's your software, new software is wrong. So that's what we did. Certainly, we assumed that if we downgrade back, it should be resolved. No, does not help. Policy is still not installed. And we started to troubleshoot just according to our workflow, right? We check config policy changes, no changes, it's just software upgrade, right? Policies were not changed. We check an OMP state. We see that the peer is up, and quite a while already, 18 minutes. We check the policy if it is assigned according to the support level command. Yes, it is. It is assigned. We verified everything. We verified policy crafting. Yes, it looks valid. Some policies defined here, no mistakes. So again, troubleshooting from a device perspective, right? Because we check it from the smart perspective according to the workflow. We check it from the device side. We need to ensure that there is a stable control connection, which is underlay connectivity for the OMP peering. And we see that it's mostly stable, but not always. We can check also OMP peering from device side, but we verified it already from the smart side. Maybe we just verify it for sake of completeness, right? Still, the situation remains the same. No policies received. Like mystery, right? 0. And we check the usual commands. No policies presented. But in the logs, sometimes router is really crying, help me. There is a problem. In the logs, we can see that sometimes the smarts are flapping. It's already a red flag for us, right? If the smart is flapping, maybe something wrong. What to do next? But what if something strange happens from a device side? Maybe device is dropping some traffic, right? If device is dropping some traffic, then we probably need to trace the traffic with help of packet trace, and there is options available how to trace it. Certainly, we will check those drops, and we can see something indeed very strange happening. Some counters increasing like crazy, right? And maybe you don't know this counter. And frankly speaking, I have seen it also first time. Really. I'm not saying that I know everything. I have seen it first time. How do we troubleshoot it? Well, let's try to see what's exactly being dropped, because we can drop on we can trace on per drop code. And we found the drop code, right? It was 206. Now let's enable the drop code tracing for the packet trace. With help of packet trace, we can see a lot of packets dropped by this reason, and then we just need to be attentive to details. If we are attentive to details and we recognize the IP addresses of packets being dropped, we will instantly realize that this is traffic from vSmart. So the policy is not programmed because the device locally itself is dropping the traffic. And again, I remind you the section about data plane and control plane. The control plane traffic processed by the data plane exactly as the traffic being forwarded through the device. So this is yet another thing which may break. Control plane traffic being dropped, and policy cannot be programmed, simply it does not arrive to the device, right? So, facts and summary so far, just quickly as a summary. No problems observed from the smart perspective. Hub router does not have policies, and they are not installed, although vSmart should be sending them as per vSmart point of view. We have some strange drop counter, and we confirm it. This is exactly traffic from the vSmart. We can guess by the name, but there is some kind of policy. Some unknown policy, not a quality of service, but a policy, right? As per the name. And reload of a device is actually a trigger, right? Not a software upgrade as such, it's not a bug, obviously, right? If we search just on Google, we do kind of the same. We have an internal knowledge base, and you can type here and you will find an internal knowledge base, but you don't need to access to it to troubleshoot it just like TAC do. This is Google, and very first output will be some discussion in the community forum saying that, ooh, QFP drops are seen with such a reason, why it is so. While reading it, you will see that there is actually a control plane policy, which is controlling on how much traffic can be processed by the control plane for the sake of DDoS protection, right? For the sake of DDoS protection, remind you that despite we have very powerful routers, when the router is reloaded, 4,000 spoke devices trying to establish data plane with it at the same time, right? Right after the reload. And by default device, ooh, it's too many. I cannot. Actually, it can. It can. By default, the policy is set to the level which cannot process so many devices at the same time. So the solution was just to reconfigure the policies and, policer, and then we can see that policy successfully arrived because the policy is processed just like another data plane traffic, right? Last but not least, this is very extremely important. I'm sure, raise your hand if you have seen issues with application classification on SD-WAN. Oh, okay. So this is unfortunately won't solve all of the problems with applications classification, but may help in some cases. So what is going on? Typical symptoms. Users say that, oh, my connection does not work, and when maybe even a technician or a junior engineer started to troubleshoot it, and he say, oh, I can ping it. No, it's pingable, destination is pingable. And probably the reason is that you remember yesterday we configured cloud on ramp. Or we enable DIA policy simply, right? This is the symptom from the user's perspective. We open the browser and their web-based application simply gives them a timeout. But at the same time, ping works just fine, right? The data policy is very simple also. There is like no room for a mistake, almost. We apply the policy saying that I have Office 365, I want to send them to a DIA, and default action is also accept. I don't want to drop anything, right? I'm not dropping anything. And this is the list as it is defined on vSmart. So we follow it with troubleshooting workflow. I intentionally skip it certainly some of the steps we were passing. This is one of the steps usually which we will do to verify matching actions. We verify it and, ooh, black hole, right? You remember, this is red flag for us. If this command saying the black hole, something bad is happening. But at the same time, black hole will typically happening for a valid reason if there is no underlying unicast routing in place. So your next step is to verify if it is actually route towards that destination. And route is here, right? And ping works. Again, it cannot be routing issue. Your ping works. It's specifically application level issue, right? So if traffic is black holed, that's reasonable assumption it must be dropped on the device. And certainly QFP drop counters were checked, but you can also actually clear them and see the recent statistics for the minute while the user was trying to initiate the traffic. No drops are seen by the device. It's quite a good confirmation that it's not your device guilty, not a router dropping the traffic here, right? We can even trace it, and we can see that traffic is being forwarded, right? This is a very interesting case, by the way, because this is what TAC engineer did before we joined it and started to troubleshoot together. The mistake was that TAC engineer didn't look into the details of that traffic. So traffic can be forwarded, but how? Sometimes maybe it's forwarded to the wrong direction, right? And yes, sometimes it can be problematic to use the packet trace, but here the NWPI will help you definitely if you enable it. You don't need to go into details of each and every packet. NWPI is smart enough. It will trace only the most critical packets, right? First packet when the classification is done, and final packet. But here it's already obvious, evident from an NWPI, red flag. And red flag is because we have upstream, traffic is sent in one direction, but not to the downstream. And within that, we can see that, oh, interesting, traffic is classified as an Office 365, right? So the traffic for the internal server, which is internal, IP address is RFC 1918, somehow got classified as Office 365 and sent to the DIA to the internet. Obviously, it cannot reach to the destination, right? The root cause now is clear. It's a misclassification, right? So why misclassification happens? This is $1 million question, actually. And sometimes this cannot be answered. But I have good news for you. Most of the time, solution is very simple, especially for such cases. It's called best practice. And best practice says that if you have a DIA policy, first make a sequence which will ensure that traffic for the RFC 1918 destinations will be excluded from the processing of your DIA policy, because you know for sure, I don't want ever to send traffic towards the RFC 1918 towards the internet, right? And yeah, this is how you do it. Just insert yet another sequence before your actual DIA sequence, saying that if destination RFC 1918, just accept it, do nothing, right? By the way, same thing may happen with Cloud RAM, just for your reference. Right? Why so complicated? Why so complicated? We thought the same. And you don't really always need to think about it. It should be automatic. And that's why starting from 20.13, like 2015, such a sequence will be automatically added as a best practice when you configure DIA, right? Enough. So we finally reached to the point, and instead of conclusion, just to summarize, typical faults, couple of slides. We are almost done. I promise you, we are almost done. Couple of slides to summarize what is going on and what are the typical policy faults. Again, for you, as a reference, during your troubleshooting exercises, maybe you scroll down to the bottom of your slide deck and you check one by one. Is it my fault? No. Is it like troubleshooting from a hip, you know? Shooting from a hip. Troubleshooting from a hip, the same. Is it my fault? No. Maybe I misconfigured default action. Maybe I applied policy on the wrong direction. Maybe policy application scope is too narrow or too wide. What do I mean by this? Maybe you applied site ID and then you forgot to define the VPN list to which you want to apply it, and you apply it to all the VPNs. Or vice versa. You decided to apply it to all VPNs, but you forgot that this policy is applicable for one specific VPN only, right? Simple misconfigurations, always possible, right? Two typos. That's why you have test policy. That's why you have show policy service path commands, just to verify actual match conditions. And always keep in mind policy processing logic. This is very common. And I'm working right now on small pet project, so-called policy linter, to help to engineers to verify if one policy sequence maybe is crossing the other policy sequence and match condition already happens in it, and maybe the other condition under it will never be happening just because we are colliding, right? This is like always collision because of a policy processing logic. As soon as the match condition happened, we are not processing the same match condition further down the policy. Okay, this was generic to all policies. Now, control policies. Remember, right? Control policy before makes a lot of difference compared to the control policy in the outbound direction. Control policy on inbound, big difference to the outbound. Set TLOC list. If you set TLOC list, this is like rewriting your next hop forcefully. Keep this in mind. Smart does not care about TLOC state. It will just do whatever instructed. It's not a misbehavior. Typical mistake, if you set TLOC action, like for on-demand tunnels, like for primary, always enable service TE. If you try to use set TLOC action and try to join multiple TLOCs, not always work. It should be the same transport towards the data plane is built and from which the data plane is built towards the final destination. It cannot be like, first we build a data plane towards business internet and then we build data plane from MPLS from the same router towards the final destination. It won't work, right? Now application-aware routing data policies. Asymmetrical traffic. Sometimes you see that, oh, okay, it's sent according to my preference, but returning from the wrong interface. Why? Because it's unidirectional. If you configure application-aware routing policy, don't forget that you are not essentially influencing return traffic. You need to take care of it separately. Otherwise, it simply won't achieve your intent, right? Equal cost multipaths, always necessary. Otherwise, application-aware routing policy simply has no choice from the paths. It will always follow unicast routing. Common misunderstanding. Sometimes people don't really understand that the worst case with default parameters, even if your BFD hello is 1 second, multiplier is 7, there is an up route pole multiplier, which is 10 minutes, and multiplier is 6, which means up to worst case scenario, it may be up to 1 hour for the application-aware routing policy to change the direction of your policy application. There are also recommendations for these timers in the Cisco Data Design Guide. I definitely recommend you verifying with it. So, and certainly BFD pole interval impacts the frequency of up-route pole interval, but not application-aware routing reaction time. Common issues, data policy collides with application-aware routing policy. For that reason, you have a workflow, flow chart in my slides. Classification issues, sometimes just ensure that you see the DNS packets. If you don't see the DNS, application match cannot happen usually, because most of the complex applications are matched based on DNS, right? Or SNI, but it will not be first packet match. Fallback issues with DIA and policy stickiness. Again, it's also possible that if your policy cannot decide which type of traffic it is, and it's a TCP-based application, it will stick to the same path. Why? Because we don't want to break the TCP flow in the middle and cause connection resets while we, on the packet number 5, finally realize it that, oh, it was SSH. Let's send SSH through or Office 365. Let's send it finally towards the private one, to the internet. No, we don't want it. That's why policy stickiness may happen. You need to understand why it is happening. It's not essentially a device misbehaving, right? Fragmented packets, last but not least, sometimes it's also, like I mentioned about TCP-based applications. For UDP, there is also its own catch. For UDP-based traffic, if traffic is fragmented, in the fragment, there is no information about ports, right? And it will lead also to misclassifications. Finally, references. To acknowledge my colleagues who did the great sessions in the past. This one I especially, no, it's mine, no, not mine. This one I especially like, it's from my colleague from CX, Olivier. He is doing this kind of the same session this year. Hopefully you visited it. It explains a lot about troubleshooting on the platform level. Definitely recommend you, if you have not visited it, check on-demand library. This one from Stefan Olofsson. He left Cisco already long ago, but his session is still relevant about the policies itself, building blocks. If you are missing the concept, if it still does not make sense, maybe you are not very familiar with policies, this is your source of information on how to apply policies, what we do, how we behave. Still relevant. This is the session from very well-known internationalist marketing engineer. I know, I'm finishing. Gina. So it's about troubleshooting in general, not only policies in general. And last one from my colleague from Krakow TAC about N-bar and misclassifications. And I really thank you that you stayed with me for 18 more minutes. I promised you 10 minutes, but I'm so happy. And I really hope it will be useful for in your. Last but not least, I know it's almost finished, but don't forget to leave your feedback. And if you really need, contact me through a WebEx space, or this is my short email address, which I created specifically for you, for attendees, so you easily to remember. So you can send an email to me, and if you have any questions, or if you have tricky cases, reach out to us. We have brilliant minds here together with me. We will solve everything for you. Thank you.